What I'm going to talk about today is the most important things you need to know about gasoline, diesel, jet fuel, our products from oil, the fuels that we are using to power our transportation systems. So we've talked previously, and you can go back and look at other 10-minute takes on exploration. So we found our oil, we drilled for it, we've completed and connected the reservoir to our oil well. We're producing the oil. Now, what do we do with it? It does not come out of the ground in a form, generally speaking, in a way that we want to use it. So we have to process it. We have to refine the crude oil that we're getting out of the ground to make the fuels that we want to use. So there's 5 broad categories when you're talking about refining the oil. We do distillation, which is just really separating the oil that's in the crude oil based on its vapor pressure, its boiling points. Sometimes we crack it. That means taking long chains and making them into smaller chain molecules. This is a way of upgrading the oil from a poorer quality oil that would have really long chains into higher quality, more fluid oil that has smaller chain molecules, so smaller hydrocarbons. Sometimes we want to take the sulfur out of the oil. We want low sulfur fuels in a lot of our markets. So we have to do things to desulfurize the crude oil that we're putting into our refinery. One of the ways is to do that is with the hydrotreater. There's other processes that can remove those contaminants. A lot of times, even after doing these kind of things, we want to change some of the makeup of some of those molecules. So we can do things called reforming or alkylation. This is really combining those smaller hydrocarbons back into different shapes, depending on what upgrading we're trying to do to that fuel. And then we also blend different fuels to get different recipes depending on the mix of fuels that you're going for from your refinery. One of the things I want you to take away from our refineries, we talk about them as if they're all the same, but they're actually extremely different. Refineries in the United States tend to be refineries that can process very heavy, high sulfur fuels. So kind of the worst of the oil, crude oil. There are a lot of refineries that may only do distillation only and really have to have a very high quality, low sulfur crude oil that goes into that refinery. It's not able to process some of the heavier crudes that a lot of the United States refineries can. So not all refineries are made the same. And so each refinery has kind of a sulfur content and a heaviness or an API gravity of the crude oil that's going into that refinery that has to be within that box. What I'm showing you is actual data from Valero in the local Bay Area in terms of their crude oil inputs to their refinery. And you can kind of see the box of this is where the crude oil has to fall. They can take crude oils outside of that. They just have to blend them so that they fall somewhere within this box. So each refinery is going to have a different box on how much sulfur, how heavy or light does that crude oil need to be going into the refinery. The refinery is a really complex chemical process, starting with that distillation. So really what you're doing with distillation is just heating up the oil. And the heating up the oil, it will separate out based on how long those hydrocarbons are within that crude oil. And so you're going to get the heavier stuff, the longer chains at the bottom. You're going to get the lighter, shorter chains at the top. This is just a way of separating out. And some refineries just do this. And you can take off in the middle. This is kind of where our gasolines are, our fuel gases at the top, our diesels would be somewhere at the bottom. In the United States, we tend to have a market that really wants gasoline. So we are upgrading some of those heavier, longer chain hydrocarbons into those lighter, shorter chain hydrocarbons so we can use them for gasoline because that's what our markets are demanding. And so we're doing that primarily through cracking. So that can be a hydrocracker, a fluidized cracker. There's other ways of cracking those molecules. And you're using catalysts, you're using heat in order to break those hydrocarbons apart and upgrade those fuels. Then we're also, like I said, removing sulfur to meet our air pollution requirements on our fuels and really get the mix of fuels that we want. In the United States, as I said, we're really making it into gasoline. Over half of our oil goes into making gasoline because that's our biggest market. The other things you see on here, distillate, that's really our diesel fuels, jet fuels, other products coming out of our crude oil. So typically we're moving crude oil around the world. We've already talked about how crude oil is a global commodity. And a lot of times we're doing the refining of that crude oil into the fuels that we want near the markets where we're going to be selling it. So we don't move our products as far or as much as we do with crude oil. We still move it internationally, typically in neighboring countries where there might be excess refining capacity in one country, giving it to another country, but really it's done much closer to the markets. And so what I'm showing you here is where the world refining capacity is. So we have quite a bit in North America and Asia Pacific. In Europe, these are big consumers of the fuels in these transportation markets. Another thing I'm showing you here, because a lot of people are surprised by this, is that although we're pretty familiar with the vertically integrated oil companies like Exxon, Shell, Chevron, BP, some companies only focus on the refining part of the oil chain and the oil system. And that's where a lot of the refining is actually done. And companies like Marathon, Valero, Phillips 66, the fuels that come out of those refineries tend to go to the local stations. So in other words, just because you're buying oil from an ExxonMobil gas station doesn't mean you're getting oil that was refined at an ExxonMobil refinery. What these companies do is they tend to have a blend of additives that they add to their oils to differentiate them from each other. Chevron talks a lot about Techron, for example. It's kind of their blend of additives that might clean your engine or do other things in your engine, but that doesn't mean the oil came from a Chevron refinery. One of the things refineries have to deal with, obviously, is the air pollution, any spills, things that might impact the communities around them. One of the things we see in the United States is a disproportionate impact on communities of color or low-income communities from refineries. So what I'm showing you here is Baton Rouge. ExxonMobil has a very large refinery in Baton Rouge, and you can see how the community on the fence line around that refinery is largely a Black community. And we see this racial segregation a lot in the United States. A lot of studies have shown that the racial makeup of your community can be the #1 indicator of how close you are to something like a refinery, toxic waste dump, and other industrial processes. So very much related to redlining and intentional policies that were put in place in the United States to divide up these communities. Refineries want to have green space between them and the communities. It makes it easier for them to manage impacts to communities. This is just showing a Bay Area refinery. The ExxonMobil refinery I just talked about is trying to buy up land around it to also have more of a green space between it and the community, just to be able to help mitigate impacts. Okay, so that's about refining. Let's talk about the fuels, why we use the fuels we do, and what are some of the impacts of that. So I'm showing you both gasoline and diesel. Those are our two biggest transportation fuels in the world, and which countries use which one the most. You might see that there's a stark difference between the United States and Europe, for example, in terms of which fuel dominates. In the United States, it's gasoline, and Europe, it is diesel. There's two big reasons for this, and we're going to go into those next. One is the cost of the fuel. So diesel engines tend to cost more upfront, capital costs, so when you're buying a car, but they're more fuel efficient. And so if you have high fuel costs, like they tend to do in Europe because of taxes, you're going to be more interested in doing something like a diesel car, pay that upfront cost in order to have better fuel economy over time. The other big impact is air quality and air pollution regulations. The United States actually has had very strict air pollution regulations led by California, which we're going to talk about in a minute. That's really led gasoline to be the dominant in the United States because much of the diesel engines, especially for passenger vehicles and light duty vehicles, do not meet the strict air quality standards in the United States. That's really been led by the state of California. So let's first talk about the fuel costs and efficiency of our vehicles. So our vehicles, gasoline or diesel, they're run by a heat engine. Turning heat into work is a very lossy process. Only about 1% of the fuel you're putting in your car is actually moving you around. So it's a very inefficient process. And if we want to think about what motivates people to think about fuel economy in their vehicles, a lot of it is going to have to do with fuel cost. So what I'm showing you here is just a selection of countries and how big the tax component is for their fuel. You can see a lot of the European countries at the top of this list, the United States very much at the bottom. We have a very low gasoline tax federally in the United States that hasn't been increased since the mid-1990s. So that difference definitely impacts consumers thinking about what kind of fuel economy they want for their vehicle. You'll notice the green part of the bar, and here I'm showing you on the right, crude oil is the biggest piece of the cost of fuels. You can see it's pretty constant around the world. Again, it's a global commodity. And so when we see changes in our fuel prices, a lot of times that's having to do with the price of crude oil. So let's talk about air pollution as the other piece of this. So in the 40s and 50s, air quality in California declined dramatically, primarily due to the increase in use of automobiles. You can see here the smog in the 40s and 50s. There was a lot of pressure put on regulators to do something about this. At the same time, a professor at Caltech discovered it was really automobiles that were the challenge. So in the mid-60s, California put in its first tailpipe emission standards, formed the California Air Resources Board, and then the federal government followed, doing the Federal Air Quality Act, the Clean Air Act, et cetera. This is important because California actually, because it became before the federal government in the United States, it is able to set its own air quality standards. It actually has a waiver where it can set more strict standards than the federal government. No other state has that ability. So other states can either follow California standards or the federal standards. They have to pick one of those. It has given California the ability to lead on air quality standards. So there are lots of states that actually follow California standards. Here's just a list of them. There is obviously coordination between the federal government and California, but California's really led the way. Air quality has gotten a lot better in terms of the air pollution from transportation, but it is still significant, especially in some communities versus others. So one of the important innovations that really helped decrease air pollutants in transportation is the catalytic converter. First, we had a two-way, then we had a three-way. These helped reduce the tailpipe emissions from our transportation system. There's also a lot of additives we put in our fuels, and I'm not going to go through each of these, but we put a lot of additives in our fuel to help reduce the air pollution that's coming out of our cars, whether it's NOx and VOCs, carbon monoxide, toxic pollutants, sulfur dioxide, etc. So one of the additives we add to our fuels is ethanol. We add ethanol for a number of reasons. One is ethanol is an octane booster. You will see this at the gas station where you have different octanes. Those octanes have to do with what compression ratio that your engine needs in order to run efficiently. So it has nothing to do with the energy content. It has nothing to do with the air pollution or the quality of that fuel. It just has to do with how the engine works that you have. So typically, more luxury vehicles need the higher octane. There's no advantage of putting higher octane in a car that doesn't need it. You actually will have more air pollution out of a car if you're adding a higher octane to a car that doesn't need it. And so this was just kind of a fun fact. In 2015, Americans wasted about $2 billion paying for higher octanes than their cars needed. An additive we used to add was lead. This is an octane booster, but now I said we mostly use ethanol. It's been banned in most of the world, thank goodness, because it's really bad for our brains, our nervous systems, and the developing children. But we still use it in small aviation. Here I'm showing you concentration of lead at some local airports, some that are right near our Stanford campus, like Palo Alto and San Carlos. For small aviation, we still have leaded fuels that is impacting communities. Some places locally, like San Jose Airport, have now moved to aviation fuels that no longer have lead. Finally, just to kind of wrap this up, energy density is really important for transportation fuels. And this is why gasoline and diesel have really been our go-to for transportation fuels. They're very energy dense from both a weight and a volume standpoint. And so as we're thinking about what we want next, it becomes challenging to meet that same kind of energy density as these petroleum-based fuels. But we are transitioning, and the light duty electricity is really kind of winning out right now. In our heavy duty, our aviation, it remains to be seen whether it's going to be more synthetic fuels, hydrogen, renewable fuels. You're going to hear a lot about sustainable aviation fuel. And don't forget that there's also just mode switching as another way of reducing the impacts of our transportation system. Okay, that's it for our fuels lecture. If you want to know more, there's lots more on our website, and you guys can join the newsletter.